Assalamualaikum warahmatullahi wabarakatuh. To Dr. Wan Faida and fellow friends, I am Srinivasa binti Ahmad Fazil from AP2244A, and today I will begin the presentation from my group by share details from our case study on Piling Works, focusing on Johai Sindra Bahad. This company specializes in foundation and geotechnical engineering, which are crucial for construction projects. I will talk about the key parties involved in two important projects handled by Johai Sindra Bahad. The completed is CTC Plot 1 at Terrace, and the ongoing project is at Bukit Tungku Villa Project. Let's start with an overview of the projects and then dive into the roles of the parties involved. Johai Sindra Bahad was established in 1996 and is based in Kuala Lumpur, Malaysia. The company specializes in foundation and substructure works, including piling methods and basement wall systems. Their expertise lies in solving problems related to soil and ground stability, which is essential for safe and long-lasting buildings. Over the years, Johan has completed various projects that demonstrate their technical capabilities and commitment to quality. Let me share a recent completed project that is the CTC Plot 1 project in Cheras, with the total contract sum for piling for costly 39 million ringgit Malaysia. This project features including two high-rise apartment blocks, Block A with 42 stories and Block B with 43 stories, both blocks offering 1,334 residential units. The unit size range from 42 meter square to 118 meter square, catering to different customers' needs. The development also includes 5 levels for parking, amenities and services apartment, making it a modern and convenient living space. The project was completed in 2024, designed to provide urban residents easy access to infrastructure and lifestyle facilities like MRT. These are the parties involved in CTC project. Johan Sindra Bahad is the foundation and geotechnical specialist. They handled all piling and substructure works, ensuring the building's stability and durability. YHSA Sindra Bahad, as the architects, was responsible for designing a modern, functional layout suited to urban living. UiTM Land Berhad, as the developers, oversaw the project's financial and operational aspects, aligning it with market demand. Local authorities ensure compliance with Kuala Lumpur's building regulations, especially given the urban location. Now, let's take a look at an ongoing project constructing 4 luxury villas in Bukit Tungku, with the total contract sum for piling that costed 3.5 million ringgit Malaysia, one of Kuala Lumpur's most exclusive neighborhoods. This project is challenging because of the specific soil conditions at the site. Piling is crucial here to ensure the houses are built on a stable foundation. To address this, the team conducted a detailed site visit to gather the data and develop appropriate solutions. The parties involved in this project is Johan Sindra Bahad. Johan Sindra Bahad conducted the piling work using their expertise to adapt to the challenging soil conditions. Technical CSG engineering consultant Sindra Bahad, as the structural engineers, designed a strong and stable framework to support the villa. Lee Kowa Architect focused on creating luxury designs to match the exclusivity of Bukit Tungku. Juratras Vision Sindra Bahad, as the main contractor, oversees the construction, ensuring the use of high-quality materials and timely delivery. Local authorities monitored adherence to building codes and environmental guidelines. Before I end my presentation, I would like to conclude that Johan Sindra Bahad is a leader in foundation and geotechnical works, as shown by their completed project in Cheras and the ongoing Bukit Tungku project. Their innovative approach to piling ensures stability, safety, and efficiency in construction. Thank you.
Hi, my name is Muhammad Iqbal and I will share to you about the pile design and specification for the both of the project. For the complete project, it used port pile for its piling. The diameter of the port pile is 600 mm to 2500 mm and the depth of the port pile is 12 meter at rock socket length up to 10.4 meter and the load capacity for the port pile is 2400 to 55,200 Newton. The pile distribution or total for the pile is 318 board pile were used for this project. The reinforcement bars specification for helical bar is T10-200 for all of bars. Main bar is 20 mm diameter and main bar number per pile is 8 number to 30 number. For the ongoing project, it used micropile for all of the project. The diameter is 250 mm for all the pile. Depth ranging from 15.5 to 26.6 meter and the load capacities of 250 kN to 1100 kN. The pile distribution between the villa, it has 4 villas and the total up for the villa is Villa 1 have 59 piles, Villa 2 have 71 piles, Villa 3 has 139 piles, Villa 4 has 142 piles. Reinforcement bar for the micropile is helical bar is R8 100 for all of the bars. Main bar ranging from 16 mm to 32 mm diameter for the main bar. And the number of main bar per pile is 5 number to 6 number. The equipment and resources used for the completed project comprising of hydraulic boring rigs, BG30 mid series 1 number, BG38 or BG36 big series 1 number. And they also use vibrohammer to set 5 to 7 tons of capacity. It used 4 types of excavator and some of them are rented and some of them are owned. So the owned unit is EX200 and this is for the rented, Komatsu PC300, Komatsu PC220 and Hitachi EX300. The rental price range from 900 to 1000 day. It also have a welding set, 2 sets 500 DX rented, barbering machine 1 set rented, generator set 20 kVA 2 units rented, and also use crawler cranes 50 ton to 80 tons 2 units, but it was owned by Johannes and Bahat. For the ongoing project, it used 3 units of excavator equipped with specialized attachment for drilling and handling, a compressor, 3 large compressor for air pressure based soil excavation, welding equipment, rental equipment for securing steel casing, pile inspection machine, ensure that each pile is installed to correct depth and alignment. I already attached photo for the machinery and equipment that has been used for both project. We could see on the completed project, it has a boring rig, excavator, vibrohammer, and also a welding set. For the ongoing project, we could see an excavator that has been attached, specialized tool for boring the holes, and also an air compressor that were used to remove the excavated soil inside the holes, and also the welding unit to weld the steel casing and also the reinforcement bar. For the construction process of the both project, it has a slight similarity. So let's check it out. For the completed project, the first step is site preparation, clear and level the site, mark boreholes location for drilling. Next is borehole drilling, use hydraulic boring rigs to drill to the required depth and insert temporary casing in unstable soil. Reinforcement placement, place the steel reinforcement cage in borehole to ensure structural strength. Next is concrete pouring, pour concrete into boreholes to form piles and ensure load bearing capacity. Usually we use streamy pipe for the concrete pouring. Final adjustment, extend reinforcement to cut off level, remove excess material and extract temporary casing. For this project, on average, the team can complete 1 pile per day for smaller diameter piles and up to 5 days per pile for larger diameter piles. Next is the ongoing project. Site preparation, clear and level the site, mark boreholes location and establish access route for machinery. Borehole drilling, drill boreholes using excavator assisted by air pressure and install temporary steel casing to stabilize loose or collapsing soil. Reinforcement placement, insert steel reinforcement bars into the boreholes for added structural strength. Grouting, pour cement concrete into boreholes, binding the pile to the surrounding soil for enhanced stability and strength. Final adjustment, cap the piles, remove excess material, extend reinforcement to integrate with the superstructure and extract temporary casing. And for the ongoing project, on average, the team is capable of completing 6 piles per day with progress depending on weather condition and soil depth. The testing and quality assurance of pile for both projects is slightly different. So the complete project use instrumented maintain load test connected to assess load bearing capacity under working condition. The following piles and loads are tested, which is the B10 grade 45, B9 grade 40, and B13 grade 45. It also uses pile integrity test, and 11 piles are tested to detect voids, crack, or inconsistency, ensuring structural stability. And it also uses static load test (SLT). 11 piles are tested to verify load bearing capacity and performance under static load. And lastly, rock coring test. It was performed on 7 piles to analyze geological condition, providing essential data on the composition and strength of the underlying rock for pile stability. For the ongoing project, it uses only three types of tests. The first one is Pile Driving Analyzer (PDA). It was conducted on 8 piles. This test measures force and velocity during the pile installation, assessing load bearing capacity and identifying potential flaws. That is Maintain Load Test (MLT), applied to 10% of pile. The static load is tested over 72 hours or until it reaches 300 of the design load. The test monitors settlement to ensure the pile meets structural standards. Lastly, pile integrity test (PIT), a non-destructive test where the pile is tapped with a hammer and vibrations are analyzed to detect voids, cracks, or inconsistency in the pile.
Hi, my name is Nuzulaika. Today I will explain the problem contractor had faced during construction of piling at Taman Konat, Kuala Lumpur. For the first problem, there is delay in site possession. Normally, delay can caused by various reasons such as legal issues regarding land ownership status, insufficient permit approval, force majeure and presence of squatters. This issue may affect overall project timeline and financial of contractor due to some resources such as machineries need to be rented first. Hence, contractor need to pay penalties for cancelling or delaying the schedule, or contractor need to pay for extra for how long the project is delayed. Secondly, this project require VO for additional number of piles and depth of pile excavation. This happen may be due to unforeseen ground condition such as excessive groundwater table, weak soil layer and huge depth to find hard strata. Additional pile help to transfer load uniformly. VO require reallocation of resources to cater project timeline and it involves significant amount of money. For example, increase total number of machineries and labor on site. Hence, contractor need to pay for the additional machineries needed and to pay wages for labor on site. Lastly, since this project is located at center of Kuala Lumpur, hence it limits the movement of large machinery and transportation of piling. Normally, piling will be supplied by either 6 meter or 12 meter. So, long and high load transportation are needed to transport the piles to the construction site. It can increase transportation time due to high traffic load, hence proper route planning are required. For ongoing project Villa at Bukit Tungku, there are few problem arises during construction of piling. All of the information were received from project executive and site supervisor during our site visit. Firstly, they received complaints regarding noise pollution from the neighborhood. As we all know, construction of piling involves significant noise from its machine. Especially for this project, it requires air compressor due to micropile. Micropile involve process of inserting casing and drilling of soil. This process produce loud sound due to air compressor is used to drill and excavate soil. This affect neighborhood and prolonged exposure to the loud noise can lead to health issues such as stress, headache, and hearing loss. Failure to take appropriate measure can lead to increase in total cost and duration of the project, because neighborhood may file complaints or lodge a police report. Hence, it increased cost for contractor to pay summons and it increased duration because contractor may need to go through for court processes. Also, this site has uneven terrain and steep slope due to it is located at hillside. Hence, it limits space for working area and allocation of machineries and material storage. Also, there is high risk of accidents, especially when insufficient safety precautions taken on site, such as not wearing PPE like safety boot. Safety boot help protect us from slippery, and reporting defect, and also maintain clear work area. Clear work area is important to prevent labor from stumbling over materials on site and reduce risk of accidents. Progress of work for this site also slow and inefficient due to limited working space. During the site visit, they mentioned this site able to construct 6 to 10 piles per day and also limit up to 3 per machine and 3 compressor on site. So total 6 machineries and 10 piles only can be constructed per day. Lastly, several pile testing are needed and it takes several days to complete. For example, they need pit test, MLT and PDA test. Pit test is pile integrity test, MLT is maintain load test, and PDA test is dynamic load testing. For pit and MLT test, they have no problem because it has to be done once, but PDA test require 8 time of testing because they need to achieve 300% of pressure. Hence, for this project, it takes up to 3 days, which is equal to 72 hours to achieve that pressure. Achieving desired pressure are important to ensure the pile are able to withstand structural load. Failure during test can increase total cost and duration of project.
Alright, next, my name is Akila. From the problem from the cities project that have been explained before, there are a few solutions to overcome the challenges. First, delay on site position, which to avoid this contractor and stakeholders need to align on the site position and keep open communication each other to better quickly resolve the issue. Next, for the VO from the unexpected condition, the solution is a site survey before and during the construction to minimize the unexpected issue. Lastly, a problem on site access for the machineries on site. So contractor need to identify to make alternative routes and also use the flexible machines which can be adjusted to easier for the limited road space. Next, the solution for the Villa Bukit Tungku project. First problem occur from this project is noise pollution from the piling work. So to avoid this, contractor can consider to build the temporary noise barrier or temporary retaining wall to reduce the noise of the piling work. Next, the problem of narrow and steep slope area. So the solution is to build the temporary work platform to create a flat surface for the machineries. So it is easier to machineries to carry out the work and the movement of the machineries. And lastly, it takes a long time for by testing. So it can speed up the time with testing the multiple spice add-ons at one time, and also really prepare all the equipment for testing to keep all the work on track.
In my opinion, to overcome issues of delay in site possession, digitization of permit management can be implemented. For example, permit can be applied via online and can also track the status of approval. Conducting pre-project analysis also help prevent such delay. It need to be done before awarding contractor to identify potential risks that may affect site possession. Next, real-time data integration such as BIM software can minimize number of variation order. So what is BIM? BIM is a technology that produces 3D design. From this 3D design, we can assess potential risks that may be arise in the future. Hence, contractor can mitigate the risk or come up with new method of construction to overcome such risks from happening. Also, regular training for project manager and site engineer can help enhance their skill in managing site and increase skill of decision making to decide either the work require VO or not. Lastly, innovation of equipment such as hybrid piling rig can be used instead of heavy piling machine for site that has restricted access. Also, collaboration with third parties such as companies that are expert in logistics and transportation can help overcome barriers to the construction site. They help create access strategy to transport pile to the site, especially this site is located at high development area and has frequent traffic congestion.
Okay, next, before this, we had explained about the solution and challenges for the both of project. So this is the recommendation for Villa Bukit Tungku project for the future project, which first are open communication with a local community, which give the information and schedule timeline for the noisy operation, which help to prevent legal issues and the complaints for the local community. Next, use a flexible machineries which can be used at confined area and uneven ground like slope area, which also suitable for any kind of work because it's adjustable machineries. So it's suitable for any kind of work at the any kind of area of the work. Lastly, contractor must consider to increase the number of team worker for the testing work or other kind of work that can reduce the delays, and it also improve the efficiency of the work and minimize the disruption to the local community.
Assalamualaikum. My name is Ifan bin Nazir Amin, and I'll be comparing both of my team's case study between case study 1 and case study 2. Before comparing, let's look at the similarities. Both project involves complex geotechnical conditions that require specialized piling solutions. Each project incorporates rigorous testing and quality assurance measures to ensure the structural integrity of the pile. Additionally, temporary steel casings are employed in both projects to stabilize the boreholes during the installation process. As we can see in the slides, based on case study 1 and case study 2, we can see the project titles, location, date of possession, contract periods, completion date, and type of pile. For case study 1, we are using ball pile, and case study 2 is using micro pile. For case study 1, the method of installation. Project 1's bore piling involves the site preparation, borehole drilling, with temporary casing, placing reinforcement bars, and pouring cement grouts. Piles are capped and connected to the superstructure with 6 piles completed daily. The project will finish in 6 months. Comparing to projects 2, micropiles are installed using hydraulic rigs, excavators, and specialized equipment. After site preparation, boreholes are drilled, debris is cleared, and steel reinforcement cage are placed before pouring concrete. Smaller piles takes a day, larger ones up to like 5 days, with completion sets for 6 months. The differences between these tools: Project 1 use larger diameter boreholes with deep rock sockets, while Project 2 is using micropiles with smaller diameters, ideal for confined space and challenged soil. So for this project, they are constructing bungalows, so it's more suitable for micropiles to use. And problems and solution. Ballparks, the CTC project faced delays in site possession, variation orders due to unforeseen ground condition, and logical challenges with machineries in a dense urban area. Solutions for this is includes better pre-construction planning through site surveys and improve logistics to minimize delays and optimize resources. For case study 2, the problems and solution is Macropile, the Villa Bukit Tungku projects dealt with noise pollutions, steep terrain, and lengthy power testing. Solutions involve using noise barriers, scheduling work hours to reduce disturbance, building temporary platforms for machineries, and streamlining power testing to maintain progress. Continuing on effective and efficiency, starting from Project 1, the use of Bhopal proved highly effective in handling large loads, providing stability in complex soil conditions. The pile diameters are customized, allowing for tailored solutions to meet specific structural demands. This installation process involves precise work using advanced equipment, but larger piles can take up to 5 days to complete. As for Project 2, the micropass system is effective because it works well in tight space and on difficult soils, providing strong, stable foundations. It's efficient since it causes less noise vibration, speed up construction, and minimize impact on nearby areas. You can imagine using ball piles in a crowded area, in a small area. It's going to be very loud, it's going to be very messy. Lastly, for our comparison, we will talk about cost analysis. Project 1 has a total cost of 39 millions, which covers high-grade materials, skilled labor, advanced machineries, and testing. The projects involve significant investment in premium materials to meet high loads requirement, while costs for labors and equipments are balanced through the use of advanced machineries and skilled personnel to ensure precise and performance. As for project 2, it has a total cost of 3.5 million, including expenses for material, labor, and equipment rentals and testing. The focus is on material optimization, particularly in minimizing waste and optimizing cement usage for cost efficiency, while smaller old machinery helps reduce rental expenses and streamline installation, contributing to overall cost savings.
To summarize, the first project, the Conrad 1, used ball pile design for high load capacities. It faced challenges such as delays in site position, unforeseen ground conditions, and logistic issues in a busy urban conditions. They were resolved through detailed planning, advanced site surveys, and improved logistics. The second project for Villa Bukit Tungku used micropiles suitable for limited spaces and steep terrains. The challenges include noise pollution, difficult topography, and time-consuming in pile testing. Solutions like noise barriers, temporary platforms, and simulations testing help to overcome these challenges. In conclusion, ballpiles are ideal for large, heavy structures, while micropiles are better for constrained and uneven sites. The key takeaway is that advanced planning, innovative technology, and effective communication are critical for overcoming construction challenges. Thank you.